Right, so hi everyone. I'm really glad so many people could join. And I guess if everyone's in place, we can get started. So let me start screen sharing. All right, so today's Tech Talks topic is the comparison between React Native, the most popular cross-platform mobile development tool, and native mobile development. So before we jump into that, I think it'd be useful to briefly cover the basics and see what mobile applications are and what are the ways to deliver that to your device. So can anyone define a mobile application? Just, in your own words?
Yeah, that's an application that we install on our mobile devices. There are Android applications and iOS applications. They can be built using native platforms like iOS and Android and native languages, or they can be used using frameworks like React Native or Xamarin, Ionic.
Yeah, that's a great explanation, and I would actually extend it just a little bit. I would personally define mobile applications as apps that just run on your mobile device, that being a phone or a tablet. And using this pretty obvious and straightforward definition, we could split mobile applications into a few groups, each of which has its own advantages, disadvantages, and limitations. So we got web applications that are created using web development technologies, but still may be run and interacted with on mobile devices. We will briefly touch on these just to get more context on what options are out there besides React Native and native mobile languages. So there are native applications that you mentioned. They are created using native development languages and are dedicated specifically to a single platform. Examples of such languages are Apple Swift for iOS or Kotlin for Android. And then we got hybrid applications that are written in a single language and represent a single project, but thanks to certain magic that happens under their hood, they may run on multiple different platforms, and React Native is used to create exactly such applications. So let us dive into more details on each of these groups. So first of all, let's say a few words on web applications. These are apps written using HTML to structure elements on the page, CSS to make it look nice, and JavaScript to make it interactive. It might be some other scripting language like PHP, for example, but JavaScript is just the most popular one today. Now, why would we even talk about web apps in the scope of mobile development? Well, because they indeed are apps that you can run on your mobile device. The only thing that is they run in browsers. In order to access those and interact with it, you need to go to a certain URL on the internet, load that web page in your Google Chrome or Safari or whatever you're using, and hope that these apps have a mobile version of the layout, just so it's easy to interact with it on your phone. Now, what is good about having a product run on people's phones as a web app? Well, first of all, it's really easy to build. As I mentioned, it mostly relies on using the most basic stuff like HTML, CSS, and JavaScript, and allows using different web frameworks like React, Angular, or Vue.js. And that basically makes development of complex web applications easier and faster. It's also pretty easy to maintain because you only have a single code base that compiles into a single application accessible by any device with a browser, no matter which operating system it has installed. There are some minor differences in how different browsers render certain UI elements, but in 99% of the cases, it's the same. And last but not least, it's really cheap compared to hybrid or native applications, since you only need to maintain a single code base and only a single code base needs to be written. Now, for the downsides, in most cases, web apps need a browser to run. So people need to open a browser and go to a certain URL to access it, which is far from ideal. And I will double tap on why it's not always the case in just a minute. then they have somewhat worse user experience than native or hybrid apps. Like take Instagram, for example. You can immediately notice how button presses, scrolling, and animations and so on feel not as good in the browser as they do in the native application installed on your phone. And manually reaching the same level of interactivity and responsiveness in web as you got out of the box in native is really challenging. And the last thing is that device utility interactions are very limited. So at most, you can access the camera, payments, or geolocations of the device, but more sophisticated things like Touch ID, media player, calendar, face recognition, accelerometer, battery, and so on are inaccessible. All those things limit what your app can do significantly. Though there's one important thing to mention about web apps here. So since 2018, there's a thing called progressive web application that is now supported by Chrome and Safari browsers, and is basically a web app that developers can enable to be a progressive web app, and that can actually be downloaded to your mobile device, and you can have it kind of installed on your home screen. You can see how that works right here. So it's basically creating somewhat a bookmark for a certain website. You can download it. You can download such apps from App Store or Google Play Store only from the website. And the cool thing about PWAs is that unlike from regular websites in the browser, these can work in offline mode, so they don't need to be actually fetched from the internet. And they also can send push notifications, just like your Messenger does. Like imagine you have an online shop app and you set it up as a PWA. You can send push notifications about sales, delivery, and I don't know, other important updates when people install that on their phone straight from your website. So and all the notifications go straight to their devices. And simply knowing, say, React.js framework and ways to deploy it somewhere would be enough for this to happen. And I think it's pretty cool, and it makes a great addition to this option. A web app as your mobile, as the mobile version of your product. So to conclude, I would say that web applications is a pretty fast and cheap way to deliver your product to users' mobile device, even though it may come along with certain limitations. So native mobile development is something completely different. It's a process of developing applications for a specific operating system, and the resulting app won't run everywhere. They're created using software development kits provided by Apple and Google and introduce the best user experience and performance possible. Now, why is that? So unlike from web applications that run in the browser and talk to browser APIs to visualize things and to be interactive, native apps talk to device hardware directly. It's possible because such apps are compiled using the same language that the platform hosting them is written in. So that leads to a very fast processing speed and also application load time, because tons of visual interactive elements to be used in such app are already present in the platform itself. They're widely used in built-in applications and are optimized to the maximum. So in terms of speed and performance, this is the best fit. And if we're developing some application that involves lots of user interactions like touches, swipes, dragging, and so on, like a game, for example, or maybe some app that relies heavily on core graphics, like involves image or video editing, drawing, etc., the native mobile app is the best choice. Another important advantage of native apps is user experience they provide. So as I mentioned, they are built using platform SDKs, meaning that UI elements such as buttons, navigation, animations, etc., are consistent between built-in applications and other native apps. So in addition to a very good platform optimization, it also just feels more natural to platform users. And then native apps have out-of-the-box access to all platform-specific features. So stuff that I mentioned that is inaccessible to web application is easily accessible in native apps. So microphones, face recognition, and so on. So when developing in native mobile languages, there's no need to write any additional boilerplate code to access those. It all comes along with the native development language. Now, why do people not choose native mobile development all the time, even given all the mentioned goods? So the first thing is pricing. If you're aiming at delivering your native application to both iOS and Android platforms, you'd need two separate development teams that will be working on both versions of the app. And the differences between Android and iOS development are not just different languages with different syntaxes, but also completely different project architectures. So iOS and Android devs cannot replace one another. Not to mention that on average, native mobile developers' salaries are higher than your regular web developers. Maintenance is also a bit more complicated since all updates need to happen in both platform and need to be synced. And also development is kind of slowed down due to necessity to rebuild the app each time you make a slightest change. Say you changed a color of some button or some text, you need to recompile the whole application to see that reflected in your simulator. So that is something that slows down the development process significantly. Though all these things might not be an issue for some companies that have enough resources to stick to native mobile development, but it may definitely be noticeable complication for small companies and startups who should be as cost efficient as possible and deliver their MVP as soon as possible, right? Now, what about the tools to use when working on native applications? So Apple and Google provide their own development environments and languages to work on those. So let us start with development environments. So Apple provides us with an app called Xcode that allows you to write application code, compile the app, test it in a simulator. It supports version control and also allows defining application interface via both code and a so-called storyboard. It's a UI where you might drag elements to where they should be on the screen using the mouse, which is a quite handy tool. And a few important things to mention about Xcode. First of all, you can't install that on a non-macOS machine. So you need a MacBook or iMac to have it, or iPad. I think since 2019, they're also installable on iPads. And the second thing is it's not really useful for working on anything except Apple applications. So I tried using Xcode as an editor for my React projects, and it was completely unpleasant to work with. So Google provides us with Android Studio. On a high level, it's pretty much the same stuff as Xcode, but for Android. Plus, it does not require a MacBook to run, so you may install it on Windows or even Linux if needed. Now, what about the languages for native applications? So Apple provides us with Objective-C and Swift. Objective-C is a legacy development language. It's kind of a powerful extension of a C language, a very, very old and low-level language, and is dedicated to development for Apple family devices. Swift is a way newer replacement for Objective-C. It came out in 2014, if I'm not mistaken, and it's capable of doing same stuff as Objective-C does, but with way, way, way more user-friendly syntax. So all the new native iOS applications are written in Swift, since it's way more comfortable to work with. It's easier to read, and it actually requires less code to write. Objective-C is now mostly used to maintain legacy applications that were written a long time ago. But if a person being sourced for iOS developer position has some Objective-C background, that would definitely be a bonus, since whoever mastered Objective-C will pick up Swift super easy and fast. And basically any C family language background is also nice to have, since both Swift and Objective-C are completely compatible with any C family languages and can talk to each other. So you can basically have your C++ or C code written in your iOS application project, and it will all be compiled in a single application. The only thing you need to do is create a couple of so-called bridging headers. That is a way to explain to Swift code or Objective code that there is a certain function written in C or C++ or C# or whatever that they can use, and that's it. Android apps are developed using Java and Kotlin. So just like Objective-C, Java is also an old legacy language for native Google initially, but then Google went into a dispute with a company that develops Java, Oracle, and they decided that they need to step away from it. This is how they started cooperating with a company called JetBridge and helped them to create Kotlin that starting in 2019 is considered an official Android development language in Android documentation. So just like Objective-C and Swift, Java and Kotlin are 100% compatible, and having Java background for an Android developer position is also really good. So to kind of conclude on native mobile development, apps for both iOS and Android are developed using very powerful IDEs that simplify development process and use strictly typed languages that make the code more secure and resistant to runtime errors. And although it's the most expensive option to provide a mobile version of your product, it creates the most efficient and functional apps since it has an out-of-the-box access to all the platform features, and it has a basically instant access to devices' hardware. Now, what about hybrid applications? So just like web apps, these are referenced to as cross-platform ones, meaning you learn a single framework and are able to write apps for multiple platforms. And you also can use web frameworks to deliver hybrid apps. But how are they different from web apps in such case? So the main key difference that I would outline, they may have access to devices' native features. It may not be easy as with native apps, but it still provides access to all platform capabilities. Now, there are many different hybrid mobile development frameworks. They work in different ways. They provide different user experience. Some of them are, well, I would say a real combination of a web application and a native application in a way that they actually render a browser window inside of the application. So it's basically a browser window wrapped in a native component that basically enables that browser to talk to native APIs. It provides user experience not way better than web applications. So let us focus on React Native as one of the most popular ones at the moment, if not the popular one, if not the most popular one. And that, unlike from this web view hybrid apps that I described just now, it makes your device to render real native elements, just like a native application would. So React Native is a combination of web development technologies like JavaScript language and React.js framework for JavaScript with a native platform APIs. It allows not only to use native features like Touch ID and gyroscope, but also render real native UI elements of Android and iOS. So it's not just an imitation, it's not just a CSS representation of that. These are real UI elements rendered by the native platform. Now, you might ask, how is JS capable of talking to native APIs if nor iOS or Android are written in JavaScript? So let us first visualize what processes are running inside of a React Native application. So first of all, we have a so-called JavaScript thread. This is the one big box at the top. So this is where all the business logic of the application lives. This is where we define the components to render, in a React-like manner. We define functions that should execute whenever user clicks something, requests that need to be done to backend, and so on. Anything connected to business logic. Alongside with the JavaScript thread, and when I'm saying thread, I mean a process running in an operating system. So along with the JavaScript thread, there is a so-called native or main thread. So this process is running in any native application and is responsible for using native platform features and rendering UI. Now, in order to talk to each other, both of these processes use a so-called React bridge. And what React bridge is, it's a React native utility that receives messages from both of these threads, transforms them to a JSON object containing information about certain event happening either in JavaScript thread or in native thread, and sends that to another thread. So it works in both ways. For example, we define how we want to, how we want the screen to look like in our JavaScript. So we use React.js syntax to build the component structure on the screen. We apply styling to that. We do all these things. And once the screen is loaded, JavaScript thread sends a message to native thread, hey, here's the thing. We got these two buttons and this particular location, and also this text field right here. Left button is red and right button is blue. Can you please render it? Bridge transforms that to a JSON object of an appropriate format depending on the platform and sends it to the native thread. Native thread receives that and renders whatever needs to be rendered. And vice versa. For example, user puts their finger somewhere on the screen. Hardware registers that and notifies native thread. Native thread sends a JSON message through the bridge to JavaScript thread telling something like, hey, somebody put their finger on this particular coordinates in the screen, and you might want to handle that on your end. JavaScript thread receives that and performs necessary business logic decisions, like if it turns out that the finger was placed where certain button is located, then we might want to navigate to somewhere else, some other screen, or send a network request, and so on. And the key thing here is that React Native Bridge is smart and generic enough to automatically decide how exactly these messages should look like on different platforms. So by writing the same JavaScript code, you will have an application that renders on both iOS and Android platforms. And this right here, I would say, is this is what React Native is all about. So this is basically how it works. With all that in mind, let us define a few advantages and disadvantages of React Native. So just like in case of web applications, it has a single code base that allows writing an app that will run on different devices, right? Unlike from other hybrid frameworks, React Native actually renders real native UI components, by that being a step closer to native UX. And when I mean other hybrid frameworks, we could probably mention so-called Flutter framework. This is also a cross-platform mobile development framework developed by Google that uses Dart programming language. And unlike from React Native that does this bridge thing and explains the native platform what native, like real native elements to render, Flutter has its own rendering engine written in C++, if I'm not mistaken, and it has a built-in Material UI widget. So it looks nice, it looks good, but it does not really provide real native experience like React Native does. Another advantage of React Native, I would say, is that it's cheaper than native, just because you need to maintain a single platform and pay less to your developers. And another thing is hot reloading. So you probably remember that I mentioned that when developing a purely native application, you have this this complication where, in order to reflect any slightest change in your app, you need to recompile that, rebuild that, and that is quite time consuming. If you do that all day, you realize that you spend probably a good hour, maybe half an hour of your workday just rebuilding the app to see what, how it looks differently. And what React Native provides to us is a hot reloading. So it looks somewhat like this. On the right side, we have a simulator that is running this React Native application. And on the left side, we have our code base. You can see how just once we save the file, it actually immediately reflects whatever we changed in the code. This is lightning fast compared to what you can use in native mobile development. So this is a huge, huge advantage of React Native. But then for disadvantages, first of all, React Native does not always mean a single code base. And here's what I mean by that. So in order to access native platform features like camera or microphone or Touch ID or face recognition, we need to write a so-called native modules. Now, what is a native module? It's basically a piece of code that you write in a native mobile development language, like in Swift or Kotlin, and you put that in the iOS or Android part of your React Native project. So first of all, to understand how it all looks, React Native project is a big folder that contains mostly JavaScript code, but also contains two folders that are called iOS and Android. And the code written in these two folders is a native iOS and Android code that needs to be executed in order for React Native to be able to talk to the native platform. So some of these features they come with React Native like out of the box. For example, well, the most basic example are visual components. So you can import some view or text component from React Native library and render that in your React code, and that will be automatically converted to a native element by React Native. But if we're talking about the APIs, like the camera, you cannot just import the camera from React Native and say camera dot take a shot. Unfortunately, that's impossible. And in order for that to work, you need to write a native piece of code in Swift or Objective-C and create a so-called already mentioned bridging header that will basically describe to the React Native application that, you know what, there is this, say, Swift module that you can actually use. And yeah, basically, this is it. So you need to write a piece of native code and then bridge it to React Native so it's accessible from it. So if that's the case, if your application is aimed at having multiple native platform features, then you might actually end up having more than, not just 2 code bases, but 3 different code bases, each of which you need to maintain. So, I mean, it depends on the project, obviously. If you're confident that your application will be simple enough to not have such cases where you need to write native code, then React Native, then this is not really a disadvantage. But if you're positive that you will be using some native platform features, then you need to be ready to either write some native code alongside with JavaScript and React, or invite more developers that are, that specialize in writing native mobile applications code. Another important thing is that React Native is way less performant than native applications, primarily because all the business logic decisions that happen in JavaScript need to go through the bridge to native code. If that happens like consistently too often, that will the performance drops will become noticeable. So if we're talking about really simple application when where the users do not overuse this React bridge too much, then this performance issues will not be noticeable at all. But again, if we're talking about calculations heavy applications like games or media editors, then React Native is probably a very, very, very bad choice. And the same goes for complex designs and custom animations, custom transitions, and all that. That is also another limitations you got in React Native, just because you don't have a direct access to native UI elements. So yeah, this is pretty much it. You're limited by how exactly React Native itself under the hood translates whatever you write in React to platform code. So you cannot tweak that too much. If you need tons of custom UI stuff in your application, then React Native will be just a bad fit for that. So with having all that in mind, I would conclude that compared to native mobile development, React Native is a faster solution to deliver your product to multiple platforms, but at the same time, it comes with a bunch of limitations that will not allow you to use native platform features out of the box, and might actually lead to you writing the native code that you initially wanted to avoid. So yeah, that is probably pretty much it. React Native is good for simple applications that don't require too much customization, but it's really bad fit for apps that need to perform fast and efficient. Is it cheaper than native mobile development? Maybe. It may be cheaper if you're confident you will not involve any additional native mobile developers to participate in the project. Otherwise, it might actually get more expensive than that. Yeah, and I guess that is pretty much it from my side. Any questions, comments?
Yes, I have a question. It's about, I think it's more of understanding. As I understood from you, React Native, for mobile apps, they have to run on React Native, JavaScript, and another language, like, for example, Kotlin or Swift, or did I misunderstood?
Yeah, so let us go back here. So when we're talking about a React Native application, we're talking about two different processes running in the operating system. One is a native programming language process. So something written in Swift is running automatically once you start a React Native application. You don't participate in that. You don't need to write any code for that to happen. The only code that you write is React code. So you only write JavaScript code, you only define the business logic, and React Native framework handles talking to that native process running in the background for you. So you don't have to actually do anything for that to happen. One thing you need to keep in mind that if you need if you need to get more from that process than just running in the background and rendering native stuff, you would need to write some of native code, some additional native code for that to happen. So yeah, does that answer your question?
Yes, it does. I have another question as well. For example, if we are sourcing for a mobile app developer, what kind of stack should I look for other than React Native?
Okay, so first of all, I would say TypeScript, because out of the box, React Native may bootstrap a simple JavaScript project for you. I mean, it's still a React, it's still using React for business logic, but it's still a JavaScript project. So it does not have any typings. It's less secure, and it's more vulnerable to runtime errors. So if a person has worked with TypeScript before, that would definitely be a huge plus. Well, React, like simple React experience would also definitely be a huge plus, because, well, React framework is simply being used in React Native. So you're basically writing that same old React code, but it's not rendered on browser, it's not rendered on DOM, but rather whatever is written is compiled and sent to native platform and rendered on device screen. So if if that person has React experience, that is definitely a huge plus. I can also speak from my personal experience. So initially I was an iOS developer, and initially I knew how to write applications natively using Swift and Objective-C. But then I was moved to a React Native project, and I had to learn React Native like from scratch. And it happened so that I mentioned to do that really quickly, just because I knew how the life cycle of a mobile application works, because I knew which events may happen on screen and how one may handle that. So I want to say that having a native mobile development experience is also a good thing to have. The learning curve of React Native is definitely easier than with mobile native development. So yeah, I would say if a person knows how to write mobile applications natively, they would pick up React Native faster than if they would not know that. So yeah, React, TypeScript, and any native mobile development language experience is a good bonus.
Thank you.
Any other questions?
I actually have another one, sorry, but
Sure.
I wanted to ask if I actually have one developer that's identifying themselves as a front-end developer. Should I, but he has a React Native in his stack. Should I consider them for mobile as a mobile app developer, or I shouldn't?
Did I get it right? So they have React Native experience.
Yes.
Yeah. I would consider that person a mobile developer. Absolutely. I mean, React Native is used to develop mobile applications. So yeah, I would say so.
Thank you.
I just have a question. As far as I understand from this slide, React is used for developing the whole application business logic, and React Native is used just to be a bridge between native platforms and the React. So I thought that if you have experience with React Native, you have experience with React by default. Is it true or not?
With React by default?
Yeah.
Well, personally for me, that was not the case, because I started using simple React, not React Native, but React after I tried React Native, because, well, I was initially a native mobile developer. So that's kind of a natural transition for me from native mobile development to React Native, which also is a mobile development, but also React, and then a simple React. So I wouldn't say that, or actually, yeah, well, if you are developing something using React Native, then you are already using React. So if afterwards you go working on a simple React project, it'll be super easy for you because you already know React from React Native. Does that answer your question?
Yeah, totally.
Yeah.
And I have another question. Just want to understand how the apps are built, developed. For example, all phones have their own UI, require their own UI, right? So all phones are different. And how does it develop using React Native? I understand how it can be developed using native platforms, but what about React Native? As far as I understand, you're developing one application and then split it to different platforms, or you're developing two separate applications, but one will be used for iOS, another will be used for Android. How does it work?
Yes, a great question. So it's important to mention that whatever is generated after you compile your React Native code goes straight to App Store or Google Play Store. So app stores accept files with, well, they accept iOS files and, macOS files, iPadOS files, and so on. Google Play Store accept Android files. So React Native provides a really powerful command line client that may generate, that may compile your React Native code in different formats that you then upload to this store. So it's not like you compile all these things into a single application that is generic enough for both of these stores to accept, and for both iPhone and Samsung to be able to install. It's rather that the code written is written in a way that React Native client may generate completely different applications from that. So not just they have different formats, they have different sizes. And yeah. So it's not like it's a one generic thing. It's rather a source from which you can a single source from which you can generate two different applications for both iOS and Android. Did I understand your question right?
Yeah, you did. And when does it happen that you have, how to explain my question? So you're developing the app using React Native. It's one app, and then you compile it in accordance with the platform you're going to load it to.
Yeah.
So, and but I'm saying also that there are different UIs required.
Right. Okay. Yeah. I get it. So you mean like the buttons look differently on Android and iOS, right? The transitions look different. Is that right? Yeah,
Yes.
so this is why React Native is so great. So it does not so whatever you write for your application using React Native is sent to native platforms as simple as possible. So it's basically saying, hey, there will be this navigation button in the top left corner of the screen. iOS, can you please render a navigation button there? And iOS says, yeah, sure, I can render a navigation button because I know how my navigation button look. And the same thing goes for Android. So React Native just says, hey, there will be a navigation thing somewhere right here. Render that. And Android says, okay, I know how my navigation buttons look. I will render them accordingly. And the cool thing is that you don't even need to update your React Native code base in order to reflect the iOS updates or Android updates. So say in the next version of iOS, the button or some, I don't know, a navigation header or a tab buttons at the bottom of the page, they look differently, right? So they're updated, their looks are updated. You don't need to tweak your React Native code to reflect that, because it will be automatically picked up by the native platform, because you will still send, React Native will still send an event saying, hey, render a tab button at the bottom. And iOS says, okay, I will render that. I know how an updated tab button looks. Of course, if you want to render some custom stuff, like I want my navigation buttons at the top left corner to, I don't know, to be circle and yellow, obviously that will be, that will be reflected in both applications, because that is a custom setting that you write on your own. But if we're talking about this, guidelines stuff like generic buttons, generic text fields, right? It will all happen automatically in both native platforms, because React Native, it only says the most generic and basic stuff to them, and the platforms themselves define how exactly that should be rendered. And that is what is great about React Native, because it uses real native elements, unlike from Flutter that I mentioned earlier, for example, because Flutter renders everything from scratch.
Okay, perfect. Thank you.
Sure.
So another advantage of React Native is that you're developing an application much faster than you would using native platforms, right? Because
because what?
Because you're developing one app and then make it suitable for both platforms. And when you use native platforms, you need to have a separate team that is developing iOS application. You need to have a separate team that develops Android application. So it takes twice as much time as. So you understand? Do you understand?
Absolutely. Yeah. Absolutely. That is a perfectly correct understanding.
So another advantage of React Native.
Yes.
I have another question. What other tools can be used to develop React Native applications besides the Android Studio and Xcode?
What other tools may be used to develop React Native applications?
Yes, tools or environments.
Yeah. Okay. So first of all, Xcode and Android Studio are not used to develop React Native applications. They are used to develop native applications. So if you're writing something in Swift or Objective-C, then Xcode is your choice, while Android Studio is your choice if you're developing something in Kotlin for Android or Java for Android. And then for React Native, well, any IDE, any editor that is suitable for a developer to work with React would also be sufficient for React Native, because it's basically, it's also React. It's just using different components that are imported from different places. It has the very same syntax. It has a very same files and folders structure. So my personal preference is Visual Studio Code because it's a great balance between a really lightweight IDE. It's way lighter than any JetBrains product, for example. And it also provides you with really good, useful utilities like search, jump to definition, rename symbols, stuff like that. So yeah, I would say that Visual Studio Code is probably the best fit for React Native development. I might have not as much experience in React Native. Maybe there are some other development environments to work with that. But I would say that, yeah, anything that is suitable for React also works for React Native.
I understood. Yes, I saw VS Code quite often.
Yeah,
on developers' profiles. Thank you.
And it's super customizable too. So yeah, you can. I think VS Code also has some plugins, or yeah, I think it should have some plugins for Kotlin and Swift. So technically you can develop your native applications in VS Code too. But again, that is not something I would personally recommend, because Xcode and Android Studio have lots and lots of useful utilities for that. They have a built-in compiler, they have built-in simulators. So yeah, I would say that Xcode and Android Studio are good for native mobile development, while React Native is, Visual Studio Code is cool for React Native.
Makes sense.
I have another question. From the beginning of your presentation, you were talking about web apps. And I have a question. What's the difference between web apps and websites?
Okay, so I'm not sure I know like some kind of official answer to that question, but in my personal opinion, a website is just a statically rendered page that just contains some kind of information, and that's it. While the web application is basically an interactive website. So in my personal opinion, a website is just using HTML and CSS, just to deliver some kind of information to you in a pleasant way, while web applications are interactive. So these are websites that are somehow interacted with by user and that actually do some things. And in order to do such things, in most of the cases, JavaScript is used. JavaScript is used in Angular, JavaScript is used in React, and JavaScript is used in Vue.js. And all these frameworks allow creating web applications. So yeah, I would say that the difference is that web app is way more interactive than just a website. But again, I think that for many people, it would also be okay to don't see any difference. Like maybe I wouldn't even think about it if you wouldn't ask me. I would still consider the website and web application are the same thing. But yeah, if I would need to answer that question, I would say so. I would say that the difference is in interactivity.
Okay, great, thank you. Because I thought that these are different things, but then at my previous job, I learned that website and web app is the same.
Yeah.
And so I just wanted, and now I thought that web app is different, so I wanted to clarify it again. So just shortly speaking, JetBridge website is a web app, right?
It is, yeah, it definitely is, yeah, it is.
Thank you.
So when I was talking about the website, web apps that may run on your mobile device, so if we agree that websites and web applications are the same thing, then I would say that in the scope of this thing that I've been talking about in the scope of this presentation, these are basically websites that have a mobile layout that you can also run on your phone, either in a web browser, or if that is a progressive web application, you can kind of download that. So I could definitely call that a website here too, if we're talking in that direction.
I have a question, Roman. Just to clarify, but React Native can be used to create actual independent applications with no web browser, correct?
That's correct, yeah. That's correct.
Thank you.
I mean, any native application, and I believe that React Native has that feature too, can render a so-called web view. So a web view component is it's like a portal that leads, it's like a portal to a web browser. So you can basically stick this portal inside your native application, a native iOS application with all the native components at the top and at the bottom. But at the center of the screen, you will have that small window that actually renders a browser. So technically speaking, React Native, Swift, Kotlin, Objective-C, and Java may render a browser inside of an application. So to answer your question, I would say that it's technically possible to still render a browser inside of the application, but React Native is created to not do that. So yeah.
Okay, thank you, I appreciate it.
Yeah, no worries.
Roman, thank you so much for taking the time out and the presentation. Again, this will be posted on our Tech Talks Notion page, so if you guys want to go back and reference it. But again, thank you, Roman, so much. We truly appreciate it.
Absolutely, my pleasure.
Yes, thank you so much.
Thank you very much.
Thank you very much.